Hello guys. Welcome to our presentation. Our presentation is about how we use those classifier and XAI models to explain the predictability and the capability for explaining the final results of how we can get the loan default or by default or not by default. So primarily we did some data processing. For example, we pre-process, we conduct the skillness correction, outlier detection, data balancing by mode, and feature importance. Yeah, we generated some important features and the plot for feature importance, and also we generated several plots so that you can see the correlation between different variables. And then we move into the model architecture department. First, we conduct the PCA. The PCA analysis reveals that PC1 captures nearly 100% of the variance, indicating that feature collinearity and suggests that the dataset's dimensionality can be effectively reduced to a single principal component without significant information loss. And then we select several important features by RFE. That's basically 5 key features. And then we conduct the PyCarry model to select our best model and optimize our model. So the automated model comparison via PyCarry, our best model indicated is the ridge classifier. So we select the ridge classifier over logistic regression due to its higher AUC, that's 0.74. And so that indicates our superior discriminative power. And then we hyper tune the best model and get our confusion matrix and learning curve. So the learning curve for ridge classifier shows that while the training core increases as more data is added, the cross-validation score remains stable. And the KDE plot generated shows the distribution of predicted churn probabilities, indicating that most predictions fall between 0.3 and 0.6, suggesting the model lacks strong confidence in its classifications. We also conducted several XAI models. For example, global explanations. We use the permutation importance, SHAP PDP and 2D PDP, and a surrogate decision tree to analyze how features, and also LIME to analyze how features influence predictions across the entire data set. So this permutation importance analysis shows that all features have little to no importance, indicating the model is likely not using any features effectively or is performing poorly overall. And for local explanations, we use the SHAPs to compute feature importance. So this SHAP summary plot visualizes the impact of each feature on the ridge classifier's prediction. So this means the interest rates and job titles significantly affect the model's decisions, where higher interest rates increases the likelihood of default, while higher employment titles reduce it. And then we move into the partial dependence plots. So this PDB shows that the higher interest rates increase the predicted outcome while higher employment titles decrease, indicating their respective positive and negative influences on the model's predictions. And also the 2D PDP dependence plot shows the combined effect of the interest rate and employment title on the model's predictions, where higher interest rate and lower employment titles are associated with a greater likelihood of default. And then we train a decision tree surrogate model to approximate the predictions. As we can see, the output tree shows that the interest rate and employment title are key decision factors, but the model structure suggests that potential overfitting or weak predictive power. So finally, we use LIME to interpret the ridge classifier models. So the LIME explanation provides a local interpretation of the ridge classifier prediction for a specific instance, showing that the employment title, interest rate, and instrument contribute towards predicting not churn, while grade and loan amount are the strongest indicators of churn.
Then we come to the ethical considerations part. First, we check the buyer's identification by analyzing default predictions across income groups. And we found that a buyer's gap of 0.137 exceeding the 0.1 threshold, suggesting that the model may exhibit income-based bias in these predictions. Then we evaluate the fairness metrics by computing demographic parity and disparate. And the output shows that the demographic parity of 1.5, indicating that the highest income group is 1.5 times more likely to receive a positive prediction than the lowest income group. Then we evaluate the ethical impact of the model. And we found that the false negative rate is higher than the false positive rate, meaning that the model could increase financial risk for lenders by approving loans that might default. Finally, we evaluated the model performance, and we found that this model has 66% accuracy and AUC, but the low precision and F1 score indicate that it struggles with correctly identifying the positive class. And we also evaluate the explanation quality using SHARP from Fairness, which finds that interest rate and employment title are most important features. And the consistency shows a mean difference of 0.099 between neighborhood samples, indicating that the model's explanations are stable for similar data points. Finally, the model's interpretability is enhanced through SHARP and LIME explanations. As we mentioned before, interest rates and job titles significantly affect the model's decision. Where higher interest rates increase the likelihood of default, while higher employment title reduce it. So that's all for our practice hackathon. Thank you. 哎，前面讲的有点多，可能7分半了。
没事，
我回头要不截一下吧。
行。